Yes, Meet, noted.
Yes, sir.
Yeah. Okay, so
Done.
now let us understand about the Arsenal is not here, so we can continue. So next is the RMS, which is called the root mean square. So root mean square here. Uh, right. So what is root mean square here? Right. So we have this. Let us read it in the backwards manner. Right. So this is EMF, and then we square it, right? And then we take the average, and then we take the root.
Good.
So that is the root mean square. Okay. If we just read it backwards, then understanding this part is pretty. So what we have to do, we have to first square the EMF, then take the average, and then take
Okay,
the root.
and then root.
So this is called the root, right? So ERMS. So this is how it is right? And every circuit, so let's say you are given this 220 in the home appliances, right? So you get 220 voltage EMF or voltage, and then 50 hertz frequency. So that 220 volt is this RMS, right? Always remember that whenever they give you this RMS voltage. Okay, so let us try to calculate this. So we have to find out E square. E is this one. E naught sine
Probability.
omega t. And then we have to square it, right? So E square is E naught square and sine square omega t, right? And then we have to find out the average. So average of this function, this would be E square dt from 0 to t divided by t. This is the average, right?
Yeah.
So let us put the value. So this is E naught square and sine square omega t dt. And you have done the
Writing.
integration, right?
Divide.
So
Yeah.
yeah, so then you know that sine square function we cannot integrate, right? So this would be, so how to integrate this function, right? So we have to use the trigonometric relations. So one thing we know that, right, because we cannot integrate the trigonometric power of the function, right? So we cannot integrate the algebraic power of the integration. So we have to make them in the linear way, right? So then we have to use this cos t2 theta. And this is how much? So this is 1 or 2 cos square theta minus 1, or this is 1 minus 2 sine square theta, right? Because we know that what is cos A plus B, this is how much? So this is cos A into cos B minus sine A into sine B, right? Means.
Yes, sir.
And if we want to calculate 2 theta, so we can write this as theta plus theta. So A is theta, B is theta. So this would be cos theta into cos theta minus sine theta into sine theta. This is cos square theta minus sine square theta, right? So this is angle 2 theta and this is angle simply theta. And we can also write cos square theta as 1 minus sine square theta, right? Because cos square theta plus sine square theta, that is 1, right? So we can write cos square theta as 1 minus sine square theta. So this will become how much? 1 minus 2 sine square theta. So that is what I have written, right?
Yes, sir.
So the idea is that we can write this sine square theta in form of cos 2 theta. And then we can easily integrate that quantity, right? So let us write this one. So this is cos is 2 theta minus 1 is minus 2 sine square theta. So if we take minus in this side, so this is 1 minus cos 2 theta divided by 2. That is the sine square theta. So I can write the square function of trigonometry in the linear manner, right? So I can write sine square omega t, uh, like this is 1 minus cos of 2 omega t divided by 2. Is this clear?
Yes, sir.
Good. So now we can integrate this quantity, right? So then we can simply integrate. This would be how much? E naught square by t 0 to t, and these are two functions. So one is 1 by 2 dt, and the other one is cos 2 omega t by 2 dt from 0 to t. Right? So we have separated these two terms. So let us take this half outside, right? So this is E naught square by 2t, and first integral is 0 to t dt, and the second integral is cos 2 omega t dt from 0 to t. So the integration of dt is how much?
Sir, by 2.
No, no. So this is simply dt. So that would be t, right?
No, the last step, sir.
So this would be t, and then from t to 0. And minus of integration of cos is plus sign, right? So that would be sine of 2 omega t and divided by 2, right?
Yes,
Correct.
sir. Yes, sir.
So this would be how much? This is E naught square by 2t, and this is t minus 0, right? And this is how much? So let's take 2 omega outside. So this is sine 2 omega into t minus sine 0. So sine 0 is 0, right?
Yeah.
And this is how much? This is E naught square by 2t. This is t minus 1 by 2 omega. And this is sine of 2 into 2 pi by t into t. So this t cancel, and we have sine 4 pi. Sine 4 pi is how much? This is 0, right?
Yeah.
So sine 0 is 0, sine pi is 0, sine 2 pi is 0. So the multiple of pi is 0. So 4 pi is also 0. This is 0, right? So then what we will get? We will get E naught square t by 2. So t cancel, and we get E naught square by 2. Right, Meet?
Yes, sir.
So this is the average of E square we have got. Right. Now to calculate the RMS, ERMS is how much? That is E square average and root. So we have to take the root of this function, right? So root of E naught square by 2. So that would be V naught divided by this is the RMS value. Is that clear?
Yes, sir.
So please note down from here. And if you have any doubt, please ask.
Sir, can you zoom out a bit?
Yes. Uh, oh,
Zoom in.
oh, okay.
Yeah, the screen is.
So small. Okay. Is this
No, no, zoom out, sir.
oh, so small. This one?
Yeah,
Will you be able to see these ones?
yeah, sir.
Yes. Whenever you want me to scroll down, please. Yes. Noted. Wait.
Sir, scroll down.
Is this okay, right?
Yeah.
Yes, whenever you have noted it down, please.
Sir, can you scroll down?
It's completed.
Yeah, sir, completed.
Good. So, let me see this one out and then yeah. Remember. Okay, so the question can be asked in this way, right? So let's say they will give you that the EMF of a circuit EMF of an AC circuit is given by, let's say, E is 40 sine 3, uh, let's say 3, right? So this is given, and then you'll have to calculate what is the average EMF, right? Then you have to find out the average EMF in half cycle, and thirdly, so also you have to calculate what is the peak voltage, and then average in half, and the last one is ERMS. Right, so all these are things where we can calculate. So peak voltage is how much? How much is the peak voltage here? Let us compare it with the general thing, right? This is E naught sine of omega t, right?
Yes, sir.
So what is peak voltage?
E?
E naught, right? E naught
Yeah,
is, so E naught is how much? It's
40.
40. So this is the peak voltage, right? 40 volts. And then the second question is what is the average EMF? So that we already know that is right.
Yeah.
Third one is average EMF in half cycle. That is 2 E naught by 5. So this would be 2 into 40 divided by 5. So this is 80 by 5 volts, right? And then the fourth one, ERMS, that would be how much? E naught by, which is 40 by root 2. So root 2 into root 2, this is 40 root 2 divided by 2. So this is 20 root 2. So these are the values, right?
Yeah.
So yeah, and we can also calculate the angular frequency. So angular frequency is 3, and then we can also calculate the frequency. Frequency is 2 pi by t. So 1 by t is the frequency, right? So omega is 3, so we can calculate this frequency also. So frequency is 3 by 2 pi. So with this information, we can calculate different attributes of the AC voltage, right? Yeah, so did you understand this part?
Yes, sir.
Please note it down, and this one we know we don't need to right. Note it down, and then we will understand about the phasors and phasor diagram. Yeah, whenever you have noted it down, please. Yes, noted.
Yes, sir.
Okay, so then let us understand about okay, so before we understand phasor and phasor diagram, so let me talk about the resolution of vectors, right? So if you have a Cartesian coordinates, right? Cartesian plane, and this is the vector that you have, and this is making an angle theta, right? So this vector has a magnitude, let's say r, right? So this vector will have two components, right? One would be the horizontal component. So this is the horizontal component, and this one is the vertical component. This one or this one, right? So this one is the vertical component, and this one is the horizontal component, right? So how much is the horizontal component? Do you remember? Yes, what is the horizontal component? If this is the magnitude and this is the angle. So did you do this resolution of vectors, or do you remember? Yes. Or you have forgotten?
Forgotten, sir.
Yeah. So yeah. So whatever is the magnitude of this vector, right? So in the resolution of vectors, we can write it in the x component. Right. Let's say that we have this vector which is 3 and 2. So what would be the, we can write this 3a and 2 as 3I plus 2j, right? This position. So it will have this 3 and it will have this y component which is 2, right?
Yeah.
And this is how much? So this is root of 9 plus 4 root 30. So this is the magnitude of the vector, and we can write it in the horizontal component and in the vertical component. So let us, in a similar way, we have this vector, right? And this is the triangle that we have. So this is theta, this is r, and this is base, right? This is perpendicular, right? So let me write it in short notation that this is b, this is b. So we have to find out b, we have to find out p, and this theta is given and this r is given. So what relates this base with the hypotenuse? What relates? What trigonometric ratio relates that? Yeah, what trigonometric ratio relates base and hypotenuse? What is b by h? Cos theta, right? Cos theta is b by h, right? Means
Yes, sir.
cos theta is b by h, sin theta is b by h, right? So if we, this base and hypotenuse are related by cos theta. So if we write cos theta, this would be base, we have to find out, and hypotenuse is given r. So base would be how much? This would be r cos theta. So whenever you have a vector, so we can write its horizontal component as r cos theta. This is r cos theta. And similarly, we can write the sine theta as perpendicular by hypotenuse. So sine theta is p by r. So p is r sine. So we can write the vertical component as r sine. So whenever we have two vectors, whenever we have a vector, right? Whenever we have a vector which is, let's say this is 3, so I can write the horizontal component as 3 cos theta and vertical component as 3 sin theta. Okay, is this clear?
Yes, sir.
Yeah. So, and we will need this vertical and horizontal component in phasor type, right? So, what is a phasor? So, they are rotating vectors. Arsalan is showing which behaves sinusoid. Okay, so yeah, we will stop at here, right? And yeah, this part
Yes,
we will
sir.
discuss. Yes, hello Arsalan, assalamu alaikum. You are half an hour,
Assalamualaikum, sir.
40 minutes late. Arsalan.
Sorry, sir.
Yeah.
Forgot there was last week.
Oh, you forgot. Oh, yeah.
No, sir. I had practical exam today, right? So like I
Oh,
slept at like 2 a.m. Yes,
oh,
2 days.
yeah. That is why. That is why you
No,
are.
sir.
Yeah.
It's fine.
Yes. So yes, you are appearing to be tired. Okay, no worries.
Yes, sir. Yeah.
Yeah, so Mir, what we will do is that we will do this part in the next class. Okay.
Okay, sir.
Yeah, we'll stop it here and we'll do this part in the next class. Now, because Arsalan is also here, so what we can do that let me make a note, right? And, I have so many this one, right? So let me electric from the electric charge. I will start, right? And we are doing the second book in the previous batch. So then simultaneously we will do first book in this class, and we'll do the second book in the other class that you guys are, right? So in this way we will complete the syllabus. Why this electric charge is important? Because your whole first book is dependent upon this electric charge. So in the whole first book, we only talk about the properties of the charges, right? So I will write that information first, and then we'll understand about electric charge, right? So what are the properties of the charges that we will understand in the first book? So So in the first chapters, right, we will talk about the charges. So we have charge, right? It is a scalar quantity, and there are three scenarios that can happen, right? So first would be that this charge is at rest. So that is called the static charge. Charge is at right. So that is called the static charge. And when the charge is static, then you will have these two chapters. So one would be electric charge and fields. And the other one is this electric potential and capacity. So these are the properties associated with the charges which are at rest, right? And then we give some speed to the charge. Then the charges are moving but not accelerating. So charge is so if charge is moving that then what are the properties associated with the charge? So it will have electric current, then it will have magnetic field, right? That is the fourth chapter, and then it will have this AC, right? So this is in the, or you can also have this electromagnetic induction, EMI, and then you can have this AC. So all these property when the charge is And then in the last part, the charge is accelerated. So charge is accelerating. Then you have this electromagnetic. So this is your whole first, right? This is how this book is divided. So in all those books, you will be talking about the charges, right? And yeah, this is the 60% of your syllabus. So this carries very majority of this syllabus of the physics part. So majority of the syllabus lies in the first, right? And this charge is very crucial aspect of the first. So all the properties associated with the charge that we will talk about in the first. Okay. So in today's class, we'll start with this first chapter. When the charge is at rest, and then what is electric charge, what is field, what is force, all these things we'll talk. Okay. So yeah, you guys please note down this part, and then I'll start with the rest. Let me zoom out. Yeah, please note down this part, and then with so this fourth chapter, these four chapter are the major chapters. Right, this will take the most of the time. So these chapters are very small ones, but these four chapters are biggest chapters. So you'll have to our major time, our most of the time will go into discussing these topics, these chapters. You guys quickly note it down, and whenever you guys have noted it down, please. Yes, noted everyone. Right?
Almost, sir.
So,
Yes, sir, done.
done Mir. Yes, Mir.
Yeah, sir. Done.
Okay, so then let us talk about this first chapter, which is electric charge. So we are talking about the charges at rest. Electric charge and so first let us understand about what is this charge, right? So first is definition of charge. What is charge? It is an intrinsic property of the material by virtue of which one experience electric field, force, and potential, etc. So this is the important thing to note down here is that it is an intrinsic property. So it comes naturally with the material, right? Whatever the material it is, so it will always have some charge, whether it is zero, whether it is positive, whether it is negative. So all of the material will have some charge, right? It is an intrinsic property. So can you guys tell me another property which is intrinsic, which comes naturally with the material? Yes.
So like any intrinsic property of material.
Yeah, any intrinsic property that is coming into mind, right?
Uh, think
Right?
no, like wait, let me think, sir. Like
No, I
yes,
said
mass and all that,
yeah.
because every object has mass, right? So
Yeah, so
that's
everything.
intrinsic.
Yeah, so mass is also an intrinsic property, right? Velocity, acceleration, these are extrinsic properties, but mass is an intrinsic property, right? So
Mm.
these are the intrinsic property of the material. Okay. And then what are the features of the charge? So what are the basic features of the charge, right? So charge, so first is that it is a scalar quantity, right? And scalar quantity, you guys already, right? So scalar quantity is what? Which doesn't depend upon the direction, right? So which doesn't contain the direction. So you don't assign any direction with the scalar quantity, which require only the magnitude, right? So it is charge is just like that. We only require the magnitude to tell the charge of an object or a material, and its SI unit is its SI unit is coulomb, right? And then yeah, so the smallest charge that a material can have is 1 right? Or let me write it as so that is where E is charge on one electron. Okay, and this 1 E is equal to 1.6 into 10 to the power minus 19. So this is one. So this is the smallest charge that that material can have, right? So this is how much? 10 to the power minus 19. So this is 0.0000, and you go to the 19th order. So this small charge on the material can, right? One. And the fourth basic feature is that all the isolated atoms, so isolated atoms are neutral. Because why they are neutral? Because the number, let's say we have this sodium, right? So sodium has atomic number 11, which means that this sodium has 11 protons, right? And this has 11 electrons, where this sodium is isolated, right? It is not reacting with other atoms, and it is isolated, and it is not reacting, right? So it will have 11 protons and 11 electrons, which means that 11 protons is plus 11e, because the proton has also this charge, plus 1. Electron has minus 1 charge, right? So 11 proton has plus 11 e charge, 11 electron has minus 11 e charge. So this would be 11, 11. So this is all isolated atoms. And so these are the main four basic features of charge, right? So these things you guys have already learned, right? So we are just recapping. Okay, and then there is this basic properties of the charge. So basic properties of charge. So there are four basic properties, and we will understand them one by one. So for one is the additive nature of the charge. The second one is the quantization of the charge. Right, and third one is what? So charge is additive, charge is quantization of charge, and third one is conservation of charge. Right. And the fourth one is invariance of charge. So these are the basic property of the charge, right? So you guys please note it down, and I will discuss all these four properties. But you guys please note down. Okay. So we will do from the basic and then learn more detail. So first we'll do this basic property, and then we'll talk about the next property of the charge. Whenever you guys want me to scroll down, please add it. Yes, sir. Whenever you guys want me to scroll down, please add it. Yes, sir. Noted, guys.
Yes, sir. Scroll.
Please
This is correct.
Yes, noted, guys.
Almost ready. Sir, the fourth one, invariance of charge. Can you just explain that again?
Yeah,
I
yeah. So
understood it.
no. So I will explain all these four parts separately. So I have not explained these things. So I will.
No, sir, I understand the first three. What is the fourth one? Invariance.
Yeah. So I will talk about that when I will talk about these three. So after that, invariance is that charges doesn't depend upon the frame of reference that you are measuring, right? So if you are measuring
Hmm.
the velocities of different object, so then you will see different velocities in different frame of reference, right? Because let's say that you are in a train, you are moving in a train, and some person is outside the train, so he will see that you are moving, right? But let's say that the other person which is inside the train, so for that person you will be stationary, right? So if we change the reference frame, then the velocity will change. But this charge will remain the same. So let's say that if someone is measuring the charge and he is moving, right? So he will measure the same charge, which will be, let's say, 4 coulomb, and someone is outside the lab, so he will measure the same charge whenever it's so. In that frame of reference, the charges will be the same, right? So the charges are invariant in that because the value or the magnitude of charges, right, doesn't change in the frame of different frame of reference. So that is the invariance, right? This doesn't depend upon the velocity. Clear?
Yes, sir.
Yes, I was about to talk about these three, but after these three, we talk about. Okay, so the first one is the additive property of the charge, additive nature, right? So the total charge in a material is the algebraic sum, not the vector sum, right? Vector sum is different, but the total charge in a material is the algebraic sum of the individual charges. And so let's say we have a material which contains 4 electrons, right? Let's say 4 protons, and then let's say we have this 3 electrons, and then we have this 6 protons. Then the total charge would in this system or in this material would be simply 4e minus 3e plus 6. So total charge Q would be simply how much? 10 minus 3, 7. So this would be the total charge, right? There are no I hat, J hat, and K hat involved. So this is not like 3i plus 2j plus 5. So these will add up in the algebraic curve, right? So this is the additive nature. Total charge is just the algebraic sum of the individual charge. And then we have this quantization of the charge, right? So quantization of charge. So what is the meaning of this quantization? Quantization is made up of quanta. So quanta means a very small number, right? Very small number. And in this case, one quanta is 1, right? In our case, for the case of charge, one quanta is this small charge, 1. So quantization of charge says that the charge on a material is the charge on a material is the integral multiple of charge on one element, right? Which means that the total charge is the integral multiple of one element. This is the quantization of charge, right? Quanta mean that this is the E, which is one quanta, and total charge is just the integral multiple. This term is very important, right? Integer, so this N is an integer now. That is why we are saying that this is integral multiple. So this is an integer, right? So if you are given a material and somebody says that its charge is 3.5 E, so is this possible?
No, sir.
And yes, of course, this is not an integer, so this charge cannot pass, right? And yeah, so and somebody says that this is the charge minus 4.8, so this is also not possible, right? This is also decimal. So charges can never be these decimal numbers, right? So this is the quantization of charge. And the third one, the third one is conservation of charge that you guys have heard numerous times, right? So total charge or charges can neither be created nor be destroyed. It can only be conserved, right? Or transferred from one reaction. So one atom to another atom, one material to another material, right? So it can only be conserved. Okay, this is the conservation of charge. And lastly, the invariance that I was talking about. So invariance of charge. So charges does not depend on the frame of reference. Frame of reference, or we can say velocity. So these are the four basic properties of the charge, right? So, and please note it down, and then we will understand about the very uh, important property of the charge, right? Quickly note it down, and then we'll talk about the next. Yes, whenever you guys have noted it down, please. Yes, whenever you guys have noted it down, please.
Yes, sir, scroll down. Sir, a bit up. I didn't write the Q is equal. Yes, sir, done.
Okay, so the next property of charge is that you guys have heard that if we have a mass, right, if we have a massive body, right, and if we have this massive body, and there's some distance between them, right, so then they will feel this attraction, right? So there is this Newton's law which says that they will feel attraction, and that would be given by Newton force, and that is equal to G m1 m2 by r square, right? So this is the force of gravitation, right? Right.
Yes.
So similarly, I don't know how, but if we put and Coulomb experimented this idea, and he observed that when he put two charges together with the separation between them is r, so force is directly proportional to the product of the charges, similar like this gravitational force, and the force is inversely proportional to this r square. So he gave, when we remove this proportionality, so this was Q1, Q2 by R square, and there's this proportionality constant K. So this is called the Coulomb's law, right? Coulomb's law, and we see that this gravitational acceleration is always attractive, right? right? Right. This is always attractive because the mass is always positive. So this is always attractive. Gravity is also always attractive. But this Coulomb force can be repulsive or can be attractive depending upon the uh, polarity of the charge, right? So if these are positive and negative, then these will be attractive. If they are both the same polarity, negative, negative, positive, positive, then they will repel each other, right? Right. So this is called the Coulomb. Okay, and this value of k is where this k is 9 into 10 to the power 9 and in Newton meters square per coulomb. This is the value of k, right? And k is also equal to 1 by 4 pi epsilon naught, right? This Coulomb force, we can write it as 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the magnitude of the force, right? And this is obviously this is a vector quantity, and yeah, it's this is a force, so its unit would be Newton, right? Where this epsilon naught, so this epsilon naught is the permittivity of the free space, right? Which means that these charges are in a free space, right? So these charges are in vacuum. But if we put them in some dielectric medium, right? So then these charges will have. So if we put them in some dielectric medium, then there will be some change in the Coulomb force, and that is given by, let's say that Coulomb force in right. So this is let's say these are the two charges Q1 and Q2, and this is the separation between them R, and we have put them in some picture, right? So this is Q1 and this is Q2. So then this force will change to 1 by 4 pi E and then Q1 Q2 by R square, where this E is the permittivity of the medium. So whenever we change the medium, then this electric force will change, this Coulomb force will change. So this is permittivity of okay, and it's this is related with the dielectric constant. So this E is related with this permittivity of free space by this epsilon. So when we divide this E by epsilon naught, so that is called the relative permittivity, relative permittivity, or it is also called the dielectric constant. So this can be written as K or ER, right? Relative permittivity or dielectric constant. So E by epsilon naught is K. So then we can write E as epsilon naught. And then we can put this value in here. So this Coulombic force would become how much? 1 by 4 pi epsilon naught K Q1, Q2, and this is in the medium, right? And this is R square. So we know that 1 by 4 pi epsilon naught, this is how much? This is 1 by 4 pi epsilon naught Q1, Q2 by R square. This value we know. So that is force in the air, right? When there was no any medium, right? So this is F air divided by this is F right. So and this dielectric constant is always greater than 1. So then this F medium. So the force in the medium is always less than this air. So the Coulombic force between two charges is maximum in the air, but in the medium it is very low. Right? It is reduced by this K factor, dielectric constant. So any doubt up to this point, guys? Any doubt?
No, sir.
Okay, so please note down this one. This was just for the understanding purposes because I don't know. You can see the nature, right? So nature is so interesting because we have two different kinds of property, but they are varying like the same, right? This one and this one has the same property, same behavior, right? But these are two different properties. Yes, that is very interesting. Yes, whenever you guys want to scroll down,
Yes, sir, scroll down.
yes,
Sir,
go
can you
ahead.
scroll down?
That is greater. So Even you guys have noted it down. I have written this is K slash E, which means K or right. We can see dielectric constant or I should write it ER, relative permittivity or dielectric constant. And remember this K and K equal to 1 by 4 pi epsilon naught. These are two different values. Right? This K is 2.
Yes, sir, done.
Done. What about you, Meet? Done. Yes, Meet. Noted.
Yes, sir, done.
Yes. Yeah, Meet has been here for far side. Not 8:30. Yes. We'll stop at here, right? And in the next class, we'll talk about the superposition principle and how so. Have you guys done these vectors part before? The addition of vectors, resolution of vectors, dot product, cross product, all these things. Do you guys remember, or do you guys want me to just revise those? Because in the superposition of, let's say we talked about two charts.